Okay, in this podcast, we're going to take a look at types of chemical reactions. We're going to look at how we can classify them. Okay, so here is just a little diagram that shows the 4 of the basic types of chemical reactions. And what you see is pretty simple. You know, here you have combination, sometimes called synthesis or combination, where you just take two things and you combine them, right? It makes sense. It's combination. The terms are meaningful. Decomposition, I take something that has two components to it and I break it apart. Single replacement, I take something that has two parts and I replace one of the parts, right? Double replacement, I take two things that have two parts and I swap out partners, okay? So if we look at the types of chemical reactions, the most common way is to classify them as one of these 4 or as combustion. Okay. So we're first going to talk about synthesis and decomposition. And those are two types of reactions that are the opposite of each other. Okay. All right, so my words got a little bit garbled here, but synthesis is when I have two substances, right? And they combine to form one product. Or sometimes I can have 3 substances that combine to form one product. The general equation is I have some substance A plus some substance B, and they chemically combine together. Okay, pretty simple. If I have an ionic compound, I can predict what my product is going to be, because I'm just going to balance the charges when I bring those elements together. But if I have a covalent compound, I cannot predict what's going to happen. Okay, not based on simple rules. So let's take a look at an example. So here I have aluminum plus chlorine. So they're going to come together and form a compound. But when they do, I have to make a balanced compound, right? So because aluminum is a +3 and a chlorine is a -1, I'm going to need 3 chlorines there. So it's AlCl3. And then in order to balance the whole equation, I need to adjust my chlorine and then the aluminum. So I'm done there. When I combine lithium and sulfur, go ahead and try that one and then come back. Okay, so lithium's a +1, sulfur's a -2, so I'm going to need 2 lithium in that formula to make it a neutral compound. If I look at the next one, if I'm making N2O4, it must have come from the elements nitrogen and oxygen in their natural state, and in their natural state, they are both diatomic, so I have to show them as diatomic. And of course, I'm going to need 2 of the oxygen to make it balance. SbCl3, antimony chloride. Okay, again, it must have come from its elements in its natural state. Antimony is going to be just plain old Sb. Chlorine is diatomic. You need to balance the chlorines and then balance the antimony, and there we go. All right, so let's take a look at decomposition. It's the opposite of synthesis. And what it is I take one substance and I break it apart into 2 or more substances. Breaking things apart generally requires energy, so you will often see one of 3 things over the arrow. You will either see the triangle, which means heat, you'll see the word electricity, or you might see catalyst. Now, a catalyst is not energy itself, but it does reduce the amount of energy required to get a reaction started. So not unusual for decompositions to see one of those 3 things above the arrow. Okay, so the general equation is I have some compound AB, and it's going to break apart into its elements. Here's an example. I break apart water. It's going to break apart into its elements in their natural state, which would be H2 and O2. They're both diatomic. And I need to balance it. Okay. Let's take a look at a couple others. Potassium bromide is going to break apart into potassium and bromine in its natural state, which means it's going to be Br2, right? It's diatomic. I've got to balance the equation. Hydrogen peroxide, I'm sure you can figure out what that's going to break apart into. It's going to break apart into hydrogen and oxygen, and it's all balanced already. And then aluminum and chlorine must have come from a compound of the two. So again, aluminum chloride is AlCl3. I need 3 chlorines to make that neutral. And then in order to balance things, I need to do that. And that's going to be my balance equation, and we're going to stop right there.